Okay, to start with, I want to take a look at this worksheet that you got yesterday, and we're going to talk a little bit about samples of how to answer this first set of questions. And we're going to do the sine of 2x first. So using the Desmos, we're going to go back and look. How long does it take to complete one full revolution? If you go back to the Desmos page and type in sine of 2x, we want to see how long does it take to go from 0, from the center of the curve, and then back to that point again. And that's 3.14. If you hover over it, notice it shows you the symbol, and it will show you that, which is kind of neat within the Desmos. So for the first one, how long is the period? How long does it take for one revolution? That is pi. Again, this is noted as the period when they ask that question. Length of time it takes for one revolution. Now, this is a key idea for step 2. How many full revolutions, or what fraction of a revolution, is completed between 0 and 2 pi? So if we go back and take a look here, here is 0. So we're going to go high, 0, low, 0. That's one revolution. Back to high, and then low, and back here again at 2 pi. That's your 6.28. So that is 2 full revolutions to complete one between 0 and 2 pi. So 2. If you noticed, that's a connection to the number here. This is actually what B represents, the number of full revolutions between 0 and 2 pi. How do your answers in parts A and B up above seem to be related to the value of B? Oh, we just talked about that. So B equals number of revolutions from 0 to 2 pi. Remember, 2 pi is that 6.28 number that you see on the Desmos screen. Is the maximum and minimum height of each of the graphs affected by V? Well, if you go back to looking at the Desmos here, the height is 1. So as I put my value of B back into here that we have it matched up with, and I move this back and forth, do the min and maxes get any higher or lower than they already are at this point? And the answer to that is actually no. It just moves this coils it in and out, but it doesn't actually change the value of the heights or the mins or maxes. So we're going to put, is the max or minimum height of each graph affected by B? No, it is not. If you recall from yesterday, A is the affected piece for that and what controls that when there's a number in front. Okay, I want you to stop the video now and go ahead and complete the rest of these. When you've completed them, then turn it back on and we'll pick up with the next part. So here's how I graph using the period. What we know is that 2 is our B value. We always need to find the period. The period is 2 pi divided by B. So whatever that is, I'm going to put that number underneath from up here and in my function underneath, and that tells me pi. What I know about the circle then is that this number 2 tells me between 0 and 2 pi, there's 2 cycles. But I'm going to use what I know about a unit circle, and I'm going to divide this up. I'm always going to make 4 lines go across my x-axis, and I'm going to put whatever the period is in the last and on the last line. From here now, when I graph these, I'm going to know that each one of these represents going around my circle in a complete set. So this is 1/4 of the way from 0 going up to the top of the circle. This is back to 180 degrees. This is down under 270, and this is back to 360. So what we know about the cosine we learned the other day is the cosine goes high, O, low, O, high. So we're going to start at 1 on the cosine curve. At the first quarter turn, the cosine goes to 0. That's what the 0 means. Then at the second quarter, it is low. At the third quarter, it is back to 0. And at the last turn, it is back to high. And then we just round that out. Every cosine curve takes on this general basic shape. It is at 1 and -1 because we haven't changed or adjusted what the radius is of that circle, or there's no A value here to control that. All right, let's take a look at the sine one on the right. For this one, B equals 0.25. So my period is going to take 2 pi divided by 0.25. Well, it might be easier to convert that to a fraction. Look at it as a fourth. How do we undo division of fractions? We keep it, change to multiplication, and then flip it over, meaning we multiply by the reciprocal. And that means 8 pi is my period. This is a really slow curve. Okay, it's 1/4, so it slowed it down. So this 8 pi becomes my ending point here on my graph. Now, since we're doing a sine curve, sine starts small. It starts at the 0. So it goes 0, high, 0, low, 0. So 0, first quarter, it's high, back to 0, low at -1, and back to 0. And that's what that reference is when we remember those. So that's graphing. Now, 2 pi technically is here. So you would see 1/4 of your curve between 0 and 2 pi. That's what that means. If I continued this one here and continued it out to 2 pi, I would see 2 curves. By shortening it up this way, I don't really get the full sight seeing of that, but at least I can tell that that's what it looks like. Okay, the next thing we're going to do is put together your note kind of plan here. Now keep in mind, this is 0, this is 90 degrees if we're in degrees, or pi over 2 radians. This is 180, or pi radians. Here is your 270, or 3 pi over 2. So these are your benchmark numbers. And we finish back at 360 degrees, or 2 pi radians. So we want to kind of pay attention to this as we go. Cosine is the first coordinate, and the sine is the second coordinate. So this is a great place to take notes on. So we start small on this. So that means we're going to go 0, high, 0, low, 0. Start at 0. We've got our 4 marks, 3, 4, and this should be 2 pi since it's not altered. And we're going to go up to 1 and down to 1. So 0. We're going to go high, 0, low, 0. And we make these marks consistently every time we make a graph. The cosine graph starts high, O, low, O, high. So your 1, your -1, and your 4 marks to be able to mark each of these, high being the starting point on the y-axis, O, low, O, high. And we're going to mark that all out as we go. On the bottom, you'll see the rest of your notes here to fill that in. A is your amplitude. What this means then is when I get to the high point is marked at positive A. A low point is marked at negative A. If you reflect it and A happens to be negative, we turn the graph upside down. So we flip the highs and the lows. Okay, and these are notes you should be writing in. B again is the number of cycles in a period between 0 and 2 pi. We aren't going to deal with any negative b's, so you can cross that off for now. So 2 pi over b means you're going to take the period and take 2 pi divided by b to get your actual period. Then if we reverse this, we're not going to worry about the increments either, other than this will help you figure out, this figures scale of each mark on graph. So on the graphs up here, when I'm marking these out, my 4 lines, this, when you take the period divided by 4, will tell you what each one of these are. Right now, both of these are at 2 pi, so that's my period. So plugging it in, 2 pi divided by 4 gives me pi over 2. This gives me pi and 3 pi over 2. You can use that to sort of help you figure out what your markings on your lines are actually going to be. And we'll reserve C for another point in time. So we flip this over. We're going to do the first one together. 3 sine of 4x. We always want to find A, the amplitude. That's 3. That's my high. And -3 is my low. My period is going to be equal to 4 pi divided by 2 pi divided by 4, where 4 is your b value, or pi over 2. So I'm going to mark my graph 2, 3, 4. There's my pi over 2. And my amplitude, I've got to go up to 3 and down to 3.